We have a double act, Dr. David Ayres and Russell Butson from the University of Otago. Pleased to be chairing an international session. And the title of their talk is Managing Sensitive Data Across the Data Lifecycle. By way of a very short bio of each, David Ayres is a lecturer in computer science at the University of Otago, and his research involves wide area distributed systems with particular interest in security and efficient network communication. So there's some tie-in from Richard's previous talk. And David's particularly interested in the evolution of policy within access control systems, such as their ongoing management, in addition to what they are able to enforce at any point in time. So David is keen to undertake projects that examine how such research topics can be grounded in reality. Russell Butson is a lecturer in higher ed at the University of Otago, and his primary area of interest is the practice of collaboration, another very good topic for this stream, and particularly in the context of virtual research environments. Russell has designed and created a number of VREs in order to advance his research area. And he's been in the research domain for some years, promoting the uptake of ICT to support the practice of research, both nationally and locally at the University of Otago. And he's also a member of Otago's eResearch Advisory Group and an advocate for eResearch generally. So if you could please welcome both our speakers. Thank you very much.
Thank you, Anne. I am Russell, and the second speaker will be David. And our project is a micro picture of some of the material that was spoken about this morning by Brian. So we're looking at managing sensitive data across the data lifecycle. And really what we have here is just a response from working my personal research and also working with researchers in my position, a rationale for why we needed to be looking into some of these issues around sensitive data. And we clearly had a major need to have some sort of managed system for the amounts of raw data, particularly in that dark data area that was spoken about this morning. In Otago, we have lots of that material, particularly in the formats of video and audio that's being generated from within the health science sector. The other key issue was that as a researcher, if I am going to store my data, particularly sensitive data, I also want to have the ability to have access to it and to allow some of my research colleagues to have access to it. So researcher control was a key component of when we digitize stuff and put it into some sort of digital space, that I as a researcher have control over who has access to it. We're also looking at this whole idea of something that's been quite progressive. So just moving data that's maybe sensitive from point A to point B wasn't going to necessarily be useful in the future when we started getting more and more researchers keen to collaborate, so we needed to have some sort of position where we could store that centrally. And again, some of this is what was spoken about this morning, lots of small amounts of data, lots of files coming in from lots of different directions. I suppose the key driver that's driven what we've been playing around with at Otago is this whole issue of the ad hoc approaches that most of us as researchers have for our current raw data. And that is our hard drives, DVDs, CDs, replications all over the place, in drawers, under tables, left in bags, all over the place in multiple different formats. So ethically, how is it as PIs? How do we actually deal with saying we know what our raw data is and we know where it is, we know how many replications? So we haven't been able to do that. When someone asks to borrow our material at Otago, I'm not sure what happens in Australia, but often we will stick it on a hard drive and put it in a courier bag and send it to our colleagues. Now, when that's sensitive data, that becomes a real issue. Very few of us as researchers, certainly my colleagues, use any form of protection at all. And even if we do secure our data on a particular IT type service, we soon cancel that out when we start firing off lots of replications that we take away. So we started to look at some sort of solutions, how we deal with the sensitive data, and as I say, in our case, large amounts of audio and video data that was coming out of the health science sector that researchers were picking up with patient interviews and so forth. So the typical approach that we picked up from our IT sector was technology-centric. So all the data was going to be stored into this bucket, this place where we would stick it. But from a researcher perspective, that's not really what, as a researcher, it's not the storage that interests me. It's actually the analysis of the data. So it didn't be technology-centric and losing control over my data, and certainly the colleagues that I work with, wasn't a key solution. So we stood back and started to look with a number of my colleagues at something that was more researcher-centric. And we didn't start with the data, and we certainly didn't start with a bucket of where we were going to put it. We started with this notion that data is actually quite dynamic. It is not static. And we started to look at these two different bands, really, where the data, our raw data, was identifiable, and our area where it was unidentifiable. Our concern was around data capture, data storage, and data analysis. So those three areas became sort of key to us. We already became aware that a whole lot of the capturing devices that we had, we weren't clearing them. So from the point of view of sensitive data, often I was borrowing video cameras and audio cameras from central pool locations, and there was raw data still on them. They haven't even been cleared. So we know that data capture devices in the digital sense are quite important. We also know that the data storage is quite important. We need services or facilities to be able to put that into a central place where all of us as researchers can actually access it. That one's straightforward from an IT perspective. The first one is slightly more difficult. And the third one, as a researcher, as I say, that as most of us as researchers are interested in, isn't the storage of it, but it's the analysis of the data. That's what interests us. So even having secure storage of our files, we're keen to extract that out of there anyway and put it into other pieces of software when we start to analyse it. So from our point of view, as far as looking at a system that we can say how secure is the data across the actual data workflow, that first section was important to us. By the time we get to the second section, the working papers and outputs, we saw that as something that our library was already working heavily in this field, and so our concentration was on those first three sections. What we were really after was some system where if we did put our data into a data storage that was central, that I, as a PI, had full control over who has access and who can put it in. Not that I would be running off to an administrator and saying, I've got 4 people or 4 different groups that are going to start putting data into that repository. As most of us are involved in research, we might be running 10 projects at any given time. So as a PI, I'm responsible for the data. I sign off on the ethics application. So we want a system where the PI is actually responsible for that raw data, not someone that's in our IT section. We also wanted a system where the PI is responsible for any replications that come out of that storage. And we can't leave it in there. We need to replicate the data, put it onto laptops and hard drives. But we need a system, therefore, that's going to track whenever we do replicate that data and that it's used outside of our central storage, and that the PI becomes responsible by some system of managing those incidences that have been replicated. But our most important bit is this whole area of the applications feeding into our stored area. How do we get a system where we can have applications running beside our storage, where the data gets transferred across to those applications and where the actual applications are involved in our analysis, and maybe even then that our other groups, GH and I, can extract that data, and again, that we can track when those replications happen. So at the end of a particular project, I, as a PI, can say that certain replications were undertaken. I check that they've all been cleared, they no longer exist, and that our stored data is safe, and that our applications are actually mainly working directly in that secure environment. So we were looking at a system that allowed this whole area here, both the storage and the applications for analysis, to be in one sort of system. And if we did, as a PI, want to extract data out of that we had some business process where we were able to track that and make sure that those replications were being removed. So from a framework point of view, this is where we started from after some considerable discussions with some researchers and drawing out a particular framework. The hard part then was how do we actually implement that from a technology point of view. So I'll hand over to my colleague David, who will talk a little bit about that.
Right, a change of voice and a change of microphone technique. In terms of, I have no lapel mic. I normally wander around. You'll just have to tell me to come back if you kind of lose track of what I'm actually saying. In terms of the actual technical requirements, we actually had three particular things that stood out in terms of the context that we can take advantage of. Now, one slight disclaimer is Russell's been working on this a lot longer than I have. I only arrived at the University of Otago in February, so it's been a rapid start. One thing is that we wanted, as we said, the need for this direct management of storage by researchers. The second thing that we wanted was to make sure that the security of the storage system was going to be well explored. Note that I haven't said that we have a secure system, because it's not exactly clear what that would, it's been discussed earlier, but that's not necessarily something you can actually assure, but we certainly need to have a very good story for how the security operates. And the third part is that we wanted to take advantage of resources that are already on offer. So in the context of New Zealand, there is already a national e-science infrastructure. It is already providing services such as a data fabric, very similar to the ARCS data fabric that's provided in Australia. We wanted to take advantage of this. It's been rebranded. It was previously BestGrid. It will be relaunched as NESI, which is the new national e-science infrastructure in New Zealand. So these are these particular pointers that we wanted the technical requirements to actually meet for us. Now, a consequence of the environment we're working in is that this iROD storage middleware is likely to be the near-term target. Now, I say near-term target because it's a practical thing to latch onto now, because infrastructure is being provided and support is being provided and it facilitates national collaboration. But it's not necessarily an exclusive choice. If we discover we really cannot explore the security in the way that we need, we may need to propose that other solutions are necessary. So the iRODS acronym stands for the Integrated Rule-Oriented Data Storage System, and it's probably familiar to many of you, given that it's used in Australia and New Zealand. One of the aspects that is sort of delivered to us is because this infrastructure is already provided, some questions that have been asked of us are why we might not be able to investigate tools like SRB, which is a precursor to iRODS, but is a commercial product rather than an open source one. What about these other sort of choices that we could use? From our perspective, what we're trying to do, though, is actually fit into the infrastructure that's already been planned and provisioned at a national level, and we can propose improvements to that if we actually need to. But this is one of the key reasons why we wanted to fit in with goal number 3, which is working with a national framework, although it probably is going to complicate goal number 2, which is being able to assure the security of the system. So iRODS has access control. Now, if you're dealing with sensitive data, that's going to be an important thing that you want. But of course, it's not a core concern. iRODS came from astrophysics applications first and foremost, and other large-scale sort of biological data sets. Sensitivity is not necessarily the #1 priority. So there is access control, but it's not engineered necessarily in as a core concern from the very start of the software. Now, this is slightly difficult because it means that then re-engineering security is always challenging in infrastructure that already exists. But what is very likely to be true is pushing researchers towards using this sort of national actual sort of data fabric is better than postpacks that contain external hard disks, because at least it means that you can actually bring things into a system that you can actually track in some way. So it's going to be an improvement from the kind of malpractice, if you like, of what sort of happened before. So the system level design, this has actually changed slightly, which is pleasing because actually the university has got behind particularly Russell's energy in terms of pushing this project and is actually now going to offer some things as core services that we might have had to run ourselves on sticky tape bits of equipment. So that's definitely good to have it in the core. With respect to iRODS, what we're looking at now is that the central information technology service are likely to actually provide the actual core iRODS software. But we have this very interesting middle layer here where, because of the rule-oriented nature of something like iRODS, we want to have departments be able to specify extra rules that they can actually have customize the software for their own needs. And then at the very top, we actually have the researchers who are the users that take advantage of this framework. So we've got this interesting split between what's going to be run by departmental technicians, leading towards giving PIs complete control, and then actually what's provided as a central core service. So in terms of a technical demonstrator for goal 1, which was giving the PIs control, it really is the case that something like iRods helps you customize the software to meet your needs. So iRods out of the box allows group owners to manage the membership of groups. So this is a good starting point. However, it still has that older view on technology that you need to protect the resources. You couldn't possibly have a system that might simply allow researchers to create as many groups as they want, because what about the disk space? I mean, because these days this is simply not as much of a concern anymore. So we wanted to engineer a solution where you monitor the way the disk space usage is changing. You don't try to stop PIs actually getting their work done first and foremost. So it's actually been very easy for us to achieve a basic hacky version of a modification of iRods that facilitates PIs being able to create groups completely from scratch, and that removes the administrator out of that particular tight loop. Of course, you want to monitor the equipment, but they're out of the tight loop. I've commented that we actually want roles more than groups. That's an interest of mine as role-based access control. There's some technologies we can bring to bear on that in a more sophisticated way than simply having groups. So I was interested to have a look a little bit then into the iRod security, given that infrastructure is there already. Now, ideally, we want to do an audit of all the way through from the users through to the data access, and of course that involves the operating system and all sorts of nightmarish things that are difficult to judge the security of. However, one key point is that iRods is designed to allow organizations to collaborate, and it's this rule-based configuration that was one of the targets that I thought would be interesting to look at. The rule system should be amenable to verification. So I set out to actually try to build something that could verify the behavior of the rules that you can use to customize this software. There's lots of rule-based systems out there, but if you've got one, you may as well check whether the rule syntax works for your actual particular system. So I built an external rule parser just to actually look at this verification, and this was because it was something that was sort of easier than building it into the iRod software itself. I've started looking at version 2.5 to begin with, but thankfully iRod's version 3 has now been released in its final form, and it will be what the New Zealand data fabric moves to in the near future. So from version 2.5, one of the things that became immediately clear is if you look at the textbook and all of the documentation on the wiki, I've cleaned up their grammar slightly, but their grammar describing the rules is incomplete and incorrect. So this is a bit of a problem if you're actually going to look at verifying the properties. I mean, I'm not trying to overly criticize this. We will try to send feedback in to improve the system. They're easy, sort of easy targets to actually hit. But so despite it looking formal, it actually doesn't quite work as a complete description of what the software is doing. And as a simple example of that, if you actually try to literally read by the letter of that description of the rule grammar, you can't even parse some of the rule sets that come with the iRod software out of the box. So in terms of the rule grammar, in version 2.5, that top slide just shows you some of the horror that you actually get to deal with if you want to use the old style syntax. It's gone away, so don't worry about that, but that is actually what you would need to sort of deal with. They'd written a layer over the top that could compile down into the somewhat more ugly syntax. But if you take my parser down the bottom here, out of the box, what you're going to end up with is a very simple situation where you'll actually fail to parse some of the rules that come from the core rule data set. The reason for that I've marked on the actual grammar slide. They're missing some of the points. One of the things that they have is a condition there. One of the things that can actually happen is that you can invoke what's called a microservice, which is a little piece of software that does a particular job. They've left that out, which is why you can't actually parse their own initial rule set. So that's something which should ideally be fixed. So where are we with iRods version 3? I mean, if we're going to look at the security analysis, and I realized, I'm really looking at very much at the nuts and bolts at the bottom, but we need to provide some sort of assurances to organizations that use this software. Version 3 includes a completely rewritten rule engine. They decided that it was a bit ugly and they were going to do another one. However, one of the things that's perhaps a problem is that the parser that actually tries to understand the rule syntax is still hard-coded in terms of its behavior. Now, worse than that, there are some aspects of the way the source code works that means it's actually quite difficult to mechanically verify the way that it's going to behave, because they've used some things to make the programmers work easier, but it makes it a lot more difficult for a computer to understand what's going on. The irony is that one of the things in computer science that you generally want, writing things that parse languages is not that interesting. Normally you delegate that job to a thing that can generate you something that parses languages. A side effect of this is you get a formal description of what your language is. So I'm definitely going to be proposing that we try to move towards the iRods version 3 as it evolves. It's open source, so I can obviously contribute this back. Changes to mean that we actually end up with a more formal description of the way that grammar works. So the lessons that we've learned so far, and that's really just scratching the surface of the way that the security is going to sort of render out in this type of project. In terms of actually working across the organisations, there's a lot of hard work just in actually keeping the different needs and possibilities and understanding across the different participants of this project working. Actually extending the iROD software was as easy as it makes out. So once you can get into their headspace, it actually is amenable to that sort of extension, which is very useful for patching up the extra requirements you have in some given e-research context. From security hardening, that's going to be a lot more work, and the proposal that I will be pushing forwards is that we formalize better the way that the actual rule parsing system works, because from then you can actually start talking much more about the way the behavior works. So the conclusions really are that we have slow but real progress being made to actually include some of the sensitive data in researcher-driven data grid infrastructure. So this is good. iRODS gives us a very practical starting point for this particular work. It's working out of the box in many contexts. We actually have real video data traveling around New Zealand currently working through that infrastructure. But how the security management is going to work, that is going to be a significant undertaking. So overall, we hope to be able to contribute this work back to iRODS, and then from there, we hope that other infrastructures might be able to take advantage of it as well. No worries.
We can maybe take one question.
I have a question. You're talking about sensitive data and security. Are your researchers happy that the data are not encrypted?
Russell,
are the researchers happy that the data is not encrypted? At the moment, the researchers are happy with data being put onto hard drives and couriered around. So I think the major shift we had was when we said we want to digitise and make it more collaborative with your partners. There was a fear that they wanted ultra sort of security measures, but they've realised that anything's better than what they currently have. So I think from that point of view, no, that hasn't become an issue now.
And from my point of view on the technical side, the question then becomes how do you manage the way the encryption is being managed? Because obviously that strengthens a lot of things, and it means that your security surface area is very different. But at the same time, any decent collaborative infrastructure, you've got shared keys. Have fun. It's one of the things, you want to track the way that that's managed. That also has to come under policy. So it's much better than dealing with unencrypted data, but you still need rules and triggers and actually having management procedures in place to deal with how you track the actual propagation and revocation of keys.
Are you working with Reagan Moore? Are you feeding back into?
I haven't really been feeding back in yet because of the fact this work is reasonably fresh, but I'm looking forward to doing so. So I know Reagan personally.
You may have one question for Richard, because I apologize, we didn't have a question being taken to Richard in the previous session. If not, then there's a break now, so. Okay, well, with that, I'll conclude the session. Thank you very much. And as a gift from the organizers, David, Russell.
Thank you. Thank you very much.
Joyce can.
Thank you.